This is the last talk, so this is the most difficult subject. I'm going to be talking about how we try to change the whole of the industrial system at scale. Big change, complicated change, from the way we dig things up and grow things, to the way that we make them in the factories, to the way that we sell them and use them and recycle them at the end. We're not going to solve every one of those problems separately. We're going to look at the connections and decide where is the best place to change that system. Where is the best place to change that system? It might be a system for making cars. It might be a system for wearing clothes or building houses. It might be a system for keeping us warm or keeping us clean. So a lot of our research is system level change, and I will take us in examples up to that rather difficult subject. We were just having a conversation about how big is the target? How much change do we have to make to the industrial system? In the Western lifestyle, my lifestyle, I, as an average British person, need about 3 planets. Not just me on my own, but if everyone was like me, we would need 3 planets to keep my life working. And then I could live for 1,000,000 years and 3 planets would be enough. That's too much. How do we get it down? But what do we mean by using 3 planets? So the number of things that we have to change is large. We have to dig up less material from the ground. We have to put less pollution into the air. We have to use less energy. We have to generate less CO2 to put into the atmosphere. The list keeps getting longer. If I just talk about the big ones, the industrial system by 2050, in 32 years' time, has to learn how to make everything that we see. All of our clothes, all of the products in this room, all of our cars, while emitting 0 CO2. 0. Because the small amount of CO2 that we can emit must be left to the food system, because we all like to eat, and that system requires CO2. That's a really massive change. We're going from 100% to 0% in CO2. We have to go to about 50% in our material intensity. So the amount of the earth that we dig up to keep you fed, the amount of the earth that we dig up to give you transport and mobility and clothing and warmth, has to go to about half by 2050. The amount of water that we need, that's very regional. If you live in Norway, there's not many people, there's a lot of rain. They don't use all of their water today. They don't need to reduce their water. If you live in another country in the world, they need to reduce their water much more. They need maybe to reduce their water usage by 60%. So that's the sort of numbers. Somewhere between 50 and 70% and even 100% change is what we need to see in the next 32 years. So I hope to give you some ideas about how we're going to get on that journey. I am an optimist. I believe we can go on that journey. But I'm a very angry optimist. What keeps me awake and shouting at my students and working hard I'm angry because we do really stupid things. Today, you might have heard some really interesting solutions, some really interesting ideas, but some of the problems are stupid. The problems we're solving, we made, they're really stupid. I'm still amazed how much potato waste there is. British people love eating potatoes, but I'm amazed that we eat any, because most of it seems to be wasted. About 80% of it doesn't get into somebody's mouth. So we're growing 5 potatoes to eat 1 potato. It's just, that sort of thing makes me angry, right? These sorts of things make me angry. On average, about 50% of the food in the UK that is safe to eat, we don't eat. About a third of the weight of the building. When this building was built, about a third of the weight of this building didn't end up in the building. It was wasted. In general, across the industrial system, whether we're measuring steel that goes into cars or food that goes into chips, 90% of the material that we dig up doesn't reach the end customer. You only get to pay for the last 10% and use the last 10%. This is enormously wasteful. I like to ask people, is there anything that makes you angry? Does anybody want to tell me what they get angry about? My favorite answer, I was in a room with 300 students, the first year engineering lecture room, and there was a young man who was really wanted to tell me about what made him angry. I thought, wow, this is going to be fantastic. And I said, well, young man, what makes you angry? And he said, the way my brother eats breakfast, right? So you can be angry at different things. You don't have to be angry about pollution, right? You can be angry at, Apple's new software. Is anybody angry at anything? Or are you all nice and polite? No anger in the room. Excellent. I will remain the only angry person in the room. But I'm angry because the systems that we've built are not fit for purpose. They don't work. They worked in an old system where a very small number of people had a highly privileged lifestyle. A few 100 million people out of 5 billion people, a few 100 million people had a nice lifestyle, and the rest didn't. And in that world, we could live on one planet. I think it's not fair, right? But if we share that lifestyle, the way we have built that lifestyle can't fit within the planet. So we want to share it, but we also have to make it fit. How do we do that? And I want to give you a clue. We've got to do these 4 things. So our research tells us the first thing that we've got to do is stop being stupid. Stop being really wasteful in our systems. We just have to be efficient. I'll give you some ideas about those numbers. How far can efficiency take us? Once we become efficient, we have to start changing the way that we deliver value into the system. And I'll give some examples of that, and Ian has been talking about some other examples. If we do those 2 things, we will go a long way to reaching our target, but we will need some new technologies to come in and help us. I hope you understand. I didn't put technology first. I do not believe technology is going to save us, right? We have to stop being stupid first, right? Then we have to be clever and creative second, then we can use technology and science to help us. But even then we won't reach our targets because the systems are poorly designed. So we will need system innovation and system change. And I want to emphasize and give examples of different types of system change so that you understand what I mean. So let's talk a little bit about efficiency. I work with one of the world's most efficient factories. The Toyota factory in the UK is one of the world's most efficient places to make cars. It was, in 2001, 17 years ago, one of the world's most efficient places to make cars. But since then, it has been reducing the energy it takes to make cars by about 8% every year. It just keeps doing it. And it was already one of the best factories in the world. If the best place in the world can get better at 8% a year, then 8, then 8, then 8, then 8, then 8, and 8, and 8, and 8, and 8, and 8, and 8. If the best place can do that, what can the others do? They should do better. Today, Toyota can make 4 cars for the energy that it took to make 1 car. That's a 75% improvement without buying technology. That's what we mean by being really efficient. And you might ask, how is that possible? Well, because we do crazy stuff, right? Because we don't even know we're being wasteful. This is one of my favorites. This is the data from the worst factory I've ever seen. So on the y-axis is the amount of energy the factory is using. And every red block is the measure of energy every 30 minutes. And you can see that at midnight on Saturday night, no one is in the factory, nothing is happening, there are no robots making anything, it's just dark. The lights are off, but you cannot tell by looking at the energy. Does this surprise you? This is a company, right? If it didn't buy this energy, it would be more profitable. So why is this company throwing money away? Why is this company throwing money away? Habit. It's been doing it like this for a long time, and it works. When everybody comes into work on Monday morning, you know that the first component you make will be high quality. And if I said to you, turn the machine off on Saturday, they would go, oh, really? Not sure. Oh, we might have problems on Monday. So it's easier not to do it. This is how stupid the industrial system is. Now, this is my worst case example, but this is really close to the average performance. There are very few factories that are much better than this. There's masses of energy to be saved out there. If you squeezed all of that energy efficiency and material efficiency, did you see that Reet showed a picture of cut roll waste, the roll waste, vast quantities of material. I want to put you out of business by not making that waste. Sorry. Right? Because we as consumers are paying that company to buy that material, and we're not making it into clothes. Right? So let's just stop buying it and stop making it. Or you can upcycle it. Okay? But my perfect solution is to stop doing that to begin with. And when you go into these factories that are paying people really terrible wages to keep their costs down, and you see the amount of energy and water and material that they waste, you think maybe you should be a bit more tough on the energy and water and waste and a bit nicer to the people. We had this conversation at lunchtime. I'm a trained factory engineer, so my degree is in production engineering. Every minute of my training on how to make factories more efficient is about how to make people more efficient or how to make expensive machines more efficient. I did not get 1 minute of training on energy efficiency or water efficiency or material efficiency. That's okay, I'm really old, right? So that's not a surprise. We are still teaching people the same way today. They do not get 1 minute of energy efficiency, 1 minute of water efficiency, or 1 minute of material efficiency. And the reason is, people like me are the teachers, right? We were not taught it, we're old, but now we're doing the teaching. So maybe you should just stop me, right? And get some new teachers in. What would we do if we wanted to improve the value? You've already had a hint of this example. So I'm just going to remind you that you can take something which seems to have no value. A London fire brigade fire hose at the top, it doesn't work as a fire hose anymore. But when you cut it up, clean it, and turn it into a very well-made handbag, what is the price of the handbag? What is the value of this handbag now? Does anybody know? Did anybody look? It's about $400, $350. Wow. So you can make a $350 product from waste. I work in Brazil in favelas, and I work at one of the groups of people I work with, they make handbags from seatbelt waste. So they go to the local factory, they take the end of the seat belts, and they make handbags. You'd think it's very similar. You know, this is a product that saves lives. Seat belts save lives. How much do they ask their customers to pay? $6. What's it worth? What's the true value? Because that $6 handbag is also a product with a story. What they're terrible at is understanding the value and telling the story and getting a good price. They still make a really interesting product, but they haven't turned it into value. And that's why changing the way we think about value is really important. I wanted to give 1 or 2 examples of technology just to think, well, if we wait long enough, the scientists might help us, and these are technologies that I'm interested in. Dennis has already explained the technology in the top left-hand corner. In there, in that machine, we can put plastic waste, and out comes fuel that we can put into ships, into boats to move around the world, and it reduces the pollution because there's no NOx and SOx in that output. So we can turn it straight into a high-value material rather than waste, and it's a non-polluting, non-air polluting material. We've heard Curie talk about biopolymers. Did you know about geopolymers? There's another type of polymer that's made from silica. Silicon can create chains in the way that carbon can create chain molecules. Silicon is sand. We can make plastic from sand. Why are we making it from oil? Because when you make it from oil and you use carbon molecules, you create CO2 and carbon dioxide and global warming. That doesn't happen with silicon. So one day, maybe, the world will have plastic, but the plastic will be made from rocks, not from oil. In the top right-hand corner is one of my favorite technologies. This photograph is taken about 5 meters from my office. So there's a small research lab where one of my colleagues, Dr. Michael de Volder, he's taking recycled plastic bags that can be turned into these things called fluidic arrays. This white thing here can be made from recycled plastic bags. Then they're putting inside this some clay from the ground in a special way. And the special properties of this mean that you can put in water that is polluted, and out of the other side comes clean water. No chemistry, no energy. It's genuinely amazing technology. And in 30 years' time, maybe this is where we will all get our clean water from. But I said I wanted to give you some examples of system transformation. This is where it gets really hard. What do we mean by system transformation? There seems to be two dominant rules in designing new systems. One of them is that when you are failing to improve the performance of a system, when you are failing to come up with new ideas, you have to make the system bigger. You have to bring new variables into the problem. And the traditional engineering approach is to make the problem smaller and solve each of the problems, one after the other. So what does that look like? Well, this car company, it's a British car company. You can see the car at the bottom. And if you do a search under the name River Simple, you'll see the car being driven around. So this is a real car. One of the things that's important about this car, you can never buy it. You can only rent it, like a phone. So you pay every month and you pay every kilometer. But the really important thing, the car company put the fuel in the car. You don't pay for the fuel. You don't pay to repair the car if you crash. You don't pay to maintain the car. So you have one fixed cost. You might think that's a good deal, especially if it's cheap and the price is good, and it is a good price. Because the car company now has your money every month and the money for the fuel, they can put really good technology into this car. And I hope you understand these numbers. So in the top left in red, this car is 1 liter per 100 kilometers car. What is your car now? What is your car now? About 8, 6, 5 if you're lucky. This is 1. And this assumes it drives on hydrogen. This assumes the hydrogen is going to come from natural gas. If the hydrogen comes from other sources, it becomes 0.1 of a liter per 100 kilometers. A car that can drive at 0.1 of a liter per 100 kilometers, you can have those cars. And this car will never be wasted because it's owned by the company. So when the car is getting tired, it just goes back to the factory and comes out to another customer. So there's no waste. The car is never wasted. And it's cheaper to own than a Smart, and it's more profitable than a Porsche. How? The profit, the extra profit, is coming from selling less fuel. Over the lifetime of the car company benefits from having to buy less fuel to move you the same distance. And that becomes their profit. That's why it's so profitable. The average profit, what's the average profit on a Kia car? Anybody? Average profit on the small size Kia. Does anybody know? It's about $500, right? $500 profit on that complicated thing. This is $10,000 profit. This is really profitable car making. I just want to give you an idea. How many of you are fast fashionistas? Fast fashionistas in Britain are about 10% of the people who buy clothes, but they buy 26% of all of the clothes. They're the people who go to the shops every weekend and they buy at least one nice thing. They spend, on average, between about $75 and $100 every Saturday. And they wear the clothes, on average, one time. They don't wear it two times. On average, they have $5,000 of credit card debt. Now, some people think this is a disease. And they think that people like this should go to hospital and be retrained. Right? I want to offer a different solution. What if you had one of these cards with the 20 on it? And the 20 means that you can have 20 things in your house from the high street. But I can go into the high street, take 1 or 2 or 3 of my 20 things, and just take away 2 or 3 things back home. So I can go down on Monday and I can take a shirt and walk home with some trousers. How many clothes do you own in that system? Do you own 20 or do you own 2,000? I don't really know. I don't really care. You have as much choice as you want. The really important thing is what is the price and what is the profitability. So remember, before, people were spending between $300 and $400 every month on clothes. At $200 a month, this is more profitable. Much more profitable to give you clothes at $200 a month than to sell you clothes at $400 a month. And the reason it's profitable is we grow less cotton. So in this system, you can halve the amount of cotton grown in the whole world. And that land can go to food production. So you get more clothes, it's more profitable, and we grow more food. And it's cheaper. Why aren't we doing this? That's system transformation. And we'll start to see things like this in the journey to 2050. My last example is one of my favorites because this is a holiday island and it helps me think about going on holiday. So in the Mediterranean Sea there is an island called Mallorca, and a company that makes environmentally friendly cleaning products, a company called Ecova, in the top right, they thought we should build a factory on this island. They buy a lot of our products. It's a tourist island, so there's a lot of cleaning. There's a lot of cleaning of hotel rooms. There's a lot of cleaning of clothes. And we have to put all of our products on a boat to go out to this island. We're going to build a factory, but they had a really cool idea about how this factory would work. They said, every week we will fly a satellite over the island and we will look at the satellite data, and we will look at the weather data, and we will calculate next week this field will be ready, and that field will make 1 ton of strawberries. That's great. The farmer will be very happy. We'll sell 1 ton of strawberries. But we also know that when you make 1 ton of strawberries, you also have 1 ton of some other waste. And now I can look ahead next week across the whole island and say we were going to have 1 ton of this waste, we're going to have 2 tons of this waste, we're going to have 100 kilos of this waste, and now it's a little bit like a menu. It's like going into the fridge and trying to make a meal with whatever is in the fridge. What can we make with these waste materials? And they do some thinking about that, and they work out what enzymes they need to turn those 3 things into shampoo. And they make those enzymes in their lab, they fly it to the factory, and then they collect the waste from the farmers and they make shampoo for free. Right? For free. All of the raw materials are for free. Wow. That's a really interesting way of running a factory. Yeah? That's the type of system change that could make a big difference. And I think on that point, I'd better finish because Sana is looking at me and he's become the second angry person in the room. Thank you.
감사합니다.